comprehensive approach to calculating operational parameters in hydraulic fracturing. Currently, hard-to-recover hydrocarbon reserves confined to low permeability, poorly drained, heterogeneous, and dissected reservoirs are widely involved in development. Hydraulic fracturing, HF, is one of the most effective methods for increasing the productivity of injection, oil and gas wells that penetrate such formations. Currently, about a third of hydrocarbon reserves can only be recovered using this technology. Highly conductive hydraulic fracturing cracks make it possible to increase well production by 2 to 3 times or more. The essence of hydraulic fracturing is the injection of fluid under pressure, which fills microcracks and weeds them, and forms new cracks. If you introduce a fixing material, for example, sand, into the formed or widened cracks, then after the pressure is removed the cracks do not close. As a result, the conductivity of the productive formation increases, which leads to the intensification of hydrocarbon production. The highest efficiency of hydraulic fracturing is achieved with an integrated design approach based on factors such as formation conductivity, fracture mechanics, fracturing fluid and proppant characteristics. To implement this approach, in addition to models of fracture formation, it is necessary to create models of filtration in a system of wells with hydraulic fractures and study the characteristics of fluid flow in the vicinity of a fracture, including in heterogeneous and water-logged formations. Therefore, it seems relevant to develop methods for mathematical modeling of hydrodynamic processes in the development of oil and gas fields using hydraulic fracturing based on theoretical research and modern computer technologies. The correct selection of such parameters as the type, properties, concentration of the proppant, the type and properties of the sand carrier fluid, and the rate of injection of the mixture directly affect the efficiency of hydraulic fracturing. Therefore, the selection of the most appropriate operating dynamic parameters for hydraulic fracturing plays an important role. This process can be optimized to obtain better results. To begin with, calculations are carried out to determine the operating parameters of hydraulic fracturing. After this, the calculation and selection of dynamic hydraulic fracturing parameters begins. First, you need to select the process fluid. The type and concentration of fluid and additives depend on the formation temperature, lithology, and formation fluids. Next, you need to select the required amount and type of proppant. There are 3 main proppant parameters that affect fracture conductivity: proppant concentration, proppant size, and proppant strength. In the process of selecting the appropriate type of proppant, it is necessary to evaluate the magnitude of the closure stress cracks. Considering all the nuances in the hydraulic fracturing process, the following sequence of actions is proposed for calculating and selecting operating parameters when carrying out hydraulic fracturing. Selection. According to the geological features and tasks of the work, of the most suitable type of hydraulic fracturing to be carried out at the well. Selection of the appropriate type and composition of the working fluid, considering the geological and technological features of the well. Selection of the appropriate type of proppant. To optimize this process, it is proposed to use an automated algorithm, which should consider different brands of proppant material. Select the most effective one for a specific calculation, and make it possible to quickly reselect the type of proppant when specifying the operating parameters. Selection of the required amount of injected proppant. To optimize this process, It is necessary to consider the dependence of the geometric parameters of the fracture on the volume of injected propellant, based on previously carried out work. Next, you need to select a range of propellant amounts that can provide the required fracture parameters. Calculate hydraulic fracturing, according to the above methodology, for several variants of operating parameters and select the most effective ones that will be used during the work. This will speed up the process of calculating and selecting hydraulic fracturing operating parameters and carry out optimization, which will eliminate the need to calculate in advance ineffective hydraulic fracturing options. Also, this algorithm can be used as a basis for introducing automatic search and calculation of hydraulic fracturing in the field. Thank you for attention.